The current of a river is 3 miles per hour and a boat travels to a point 36 miles upstream and back in 5 hours. What is the speed of the boat in still water? Okay, so once again, let's go ahead and let's draw out a picture here for ourselves. So here's the river, and we know the current, let's say the current's coming down like this. The current's coming this way at 3 miles per hour. Okay, so the boat travels from a point, so let's say it's a point right here, and the boat travels upstream. That's 36 miles to this point here, so that's 36 miles it travels up to this point. And then the boat turns around and comes back down to the point it started. And it takes 5 hours. So that's 36 miles up here, and it takes 5 hours to do that round trip. So up and back is 5 hours. So 5 hours for the round trip. So going up and all the way back down takes 5 hours. Okay, so then it says, what is the speed of the boat in still water? Because we know a boat, you get out here in the Kenai and you take your boat, here's your boat right here, and you're going against the current. What's the speed of that boat going to be? Well, whatever the speed in calm water, the speed upstream, the current is going to slow it down by 3 miles an hour. So going upstream, the speed of the boat is going to be slowed down by 3. Well, what happens when the boat turns around and comes back the other way? Now the current is going to speed it up. So the speed of the boat downstream, the speed is going to be speed in calm water plus 3. Okay, so we know that we want our distance is equal to rate times time. That's our formula we're going to be using here. Okay, so the distance, okay, let's call this upstream. We'll do this as downstream. So upstream, what is the distance we're going upstream? Well, we're going upstream 36 miles. So 36 miles. What is the rate going up speed? Well, it's the speed of the boat, whatever that happens to be, in calm water. So as we're going upstream, the speed of the boat is going to be speed of the boat minus 3. And how long is it going to take us to go up? We know it's 5 hours round trip. We know it's not going to be exactly the same because the speeds are different. So let's just call that the time upstream, T sub U. Just the time, and I put a little underneath it so we know it's this time that would take going upstream. Okay, so now let's look at going downstream. Well, the distance downstream is still 36 miles, so we're coming back down 36 miles. What is our rate coming back down? Well, our rate is going to be the speed of the boat in still water, S, plus 3. And then what's our time coming back down? Well, if it takes us time, T sub U, time to go upstream, it's going to be that amount of time off of 5 hours. So time, a round trip, or time it's going to take coming back down, is 5 hours minus the time it took to go upstream. Okay, so what we have here now is we have two equations. We've got the equation 1 here, upstream equation, and equation 2 for downstream. We have two equations and two unknowns. We don't know what the speed of the boat in still water is, and we don't know what the time it takes to go upstream. So all we're going to do is substitution. And so these are equal to each other. Look at this and say, well, what's the easiest probably to solve for? Let's solve for time upstream. So the time upstream is just divide both sides by S over minus 3, so it becomes 36 over S minus 3, which makes sense in our equation here. We know that time is going to be equal to the distance divided by the rate. Distance divided by rate. So that makes sense there. So let's go ahead and plug this in, because we know that's the same value there, and we'll plug that in for it. So this becomes 36 is equal to S plus 3 times 5 minus 36 over S minus 3. Okay, now we just got to do the algebra. Let's see. In order to combine these two terms, this term and this term, we got to have a common denominator. So let's make common denominators. This becomes 36 is equal to S plus 3. Make common denominator of S minus 3. Let's multiply top and bottom here by S minus 3. So if we say S minus 3 over S minus, I'll rewrite it down here. So this becomes 5 times S minus 3 over S minus 3. We have not changed the value of this because we're multiplying it by 1. So we haven't changed that value because it's anything over itself is 1 minus 36 over s minus 3 quantity. Okay, so 36 is equal to s plus 3. So this multiply this out. This becomes 5 times s minus 3 minus 36 all over s minus 3. Because we have like terms on the bottom here. It'd be like saying 4, 6 plus 2, let's do 3, 6. 3, 6, that's 7, 6, right? Because then it's just the same on the bottom. Okay, so then this becomes 36 is equal to s plus 3 times, multiply this out, it'd be 5s minus 15 minus 36 over s minus 3. Slide this up so we have a little more room. Okay, so this 36 is equal to s plus 3. 5s minus 15 minus 36 is, what's that? Minus 51. Minus 51. All over s minus 3. Okay, so now let's clear the denominator here. So let's multiply both sides by s minus 3, s minus 3, s minus 3. We're not changing the value because we're multiplying both sides. S minus 3 is divided out, and we have s. So we have 36 times s, that's 36s, minus 3 times 36 is, what's that, 108. 108 is equal to s plus 3 times this times that quantity there, so s times that becomes 5s squared minus 51s and plus 15s minus 3 times 51, that's 150, 153, 153, minus 153. Okay, now to solve quadratic equation, we'll set it equal to 0. So let's clear the left side here. We'll set this side, make this 0. How do we get there? So we have 5s squared. Okay, let's minus 36s from both sides. So minus 36s minus 51 plus 15s. I'm going to do that on my calculator here. It's minus 72s. Minus 72s. And then let's add 108 to both sides. Plus 108. Add 108, that'd be same thing as subtracting 108 and then carrying the bigger sign gives us minus 45. Minus 45 is equal to 0. So we have a quadratic. We have 5s squared minus 72s minus 45. I don't know. That looks, I don't know if I can factor. That doesn't look like it's confactorable. Let's go ahead and use the quadratic formula. Quadratic formula is x or whatever variable we're using. In this case, our variable is s. So we'll say s is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Well, a is equal to 5. B is equal to negative 72, and C is equal to negative 45. Because remember that in the quadratic formula, in the standard form for quadratic, ax squared plus bx plus c is equal to 0. And that's where we get our a, b's, and c's. Slide this up again. Okay, so let's go ahead and plug these in. So s is going to equal negative b. So it would be a negative of negative, so it would be plus 72 plus or minus a quantity of b squared, which would be negative 72 squared minus 4 times a, which would be 5, times c, which is a negative 45, all divided by 2a, which is 5, 2 times 5. Okay, so this is equal to 72 plus or minus negative 72 squared. Negative 72 squared is going to be 5184. 5184 minus 4 times 5 is 20. Negative 20 times 45 is gives us a positive 900. All over 10. Okay, so then this becomes 72 plus or minus 5184 plus 900. Give us 6,084 all over 10. Okay, so this is the same thing then as 72 plus square root of 6,084 is 78 plus 78 plus or minus 78 over 10. So this is 72 plus 78 over 10, or 72 minus 78 over 10. 72 plus 78 is 150. So it's 150 over 10. Zeros cancel out, end up with 15. So S is equal to 15 miles per hour. And over here we have 72 minus, so this is going to give us a negative number. So we know we can't have a negative speed, so that's not going to be a solution. So the solution is the speed of the boat in still water is 15 miles per hour.